Question net 2014 June. So a particle of mass m, coordinate q, has Lagrangian. This is the Lagrangian given. Lambda is constant here. Hamiltonian should be found out here. So Lagrangian L is given that half m q dot square minus lambda by 2 q into q dot square. So here you see this is the velocity, so no potential energy term is there, so that's why this whole term is considered to be t. And I have already told you that here in this case we have to consider this as half mv square. Okay, so here you see, so if you take half common and q dot square common, inside the bracket you will get m minus lambda by 2, sorry, not lambda by 2, only lambda you will get 2. This half is taken common, lambda q, and q dot square is taken common. So here if you compare with this term with this, then you will get this is m, isn't it? This is m. So if this is m, in case of Hamiltonian, I have already told you that t plus b, here in this case t should be considered as p square by twice m. Now put this m here, then what you will get? Then h is equal to p square by twice m. Instead of m we will get m minus lambda q, isn't it? We will get this. And I have already told you this potential term v is missing here, so that is 0. So here is the answer. So which answer is correct? Which option is correct here? This option B again in this case also. So hope you have understood how to do that. Very simple. So now let's move. So this is our next question, which was asked in December 2014 net exam. So here, motion of a system, Lagrangian is given for motion of a system, and it is time dependent, and we need to find the equation of motion. So we know the Lagrangian equation of motion is given by d by dt of del L by del x dot minus del L by del x is equal to 0. Okay, so here Lagrangian is, let me use the black ink. Yeah, so here the Lagrangian is given e to the power gamma t half mx dot square minus vx. So this is the Lagrangian given. So first let us find del L by del x dot. If you find it, then you will get e to the power gamma t m x dot. Okay, and then let us find del L by del x, and that's going to be equal to minus gamma t del v by del x. So if you put those values of del L by del x dot and del L by del x in this above equation of motion, in this Lagrangian equation of motion, then what you will get? Then you will get that d by dt of e to the power gamma t m x dot plus e to the power gamma t del v by del x is equal to 0. Now if you differentiate this term with respect to t, so what you will get? You will get e to the power gamma t. Here we are going to use the product rule, x double dot plus gamma e to the power gamma t m x dot plus e to the power gamma t del v by del x is equal to 0. Now what we are going to do, so which term you can cancel here? You can consider, you can see here clearly this term, and this term. If you divide both side by e to the power gamma t, then you will get mx double dot plus gamma mx dot plus del v by del x is equal to 0. Now check the option, which option is correct. So option 1 is correct, I hope. Yes, so this is option 1. So here option 1 is correct. Okay, so now let's move on to next question. So this is our next question, June 2015 CSIR net. So here Lagrangian of a system, dynamical system in 2 dimension is given, and we need to find a Hamiltonian. So here the Lagrangian is L is equal to half mx dot square minus, sorry, not minus, plus mx dot y dot. So that should be x dot, I think. Yes, mx dot y dot. So here you see, in this case we are going to find the Hamiltonian. So what we're going to do here, so we know a relation that h is equal to summation pk, p here momentum. So here we have 2 components, x and y, so we will get px and py, and qk is position. So here we will get x and y in terms of x and y, we will get the position q k dot minus l. This relation gives the Hamiltonian. Okay, if you remember, then you should know this, I think. Okay, so here you see, then Hamiltonian is equal to, so we will get px and position q dot will be here x dot for x component, and for y component py and y dot according to this formula, then minus l. L is already given here, this is the L, half mx dot square minus mx dot y dot. Okay, this is what we have got. Now also remember these relations also. Px is given by del L by del x dot, and hence py will be given by del y by del y dot. Okay, so from px is equal to, here you see del L by del x dot, here we will get mx dot plus my dot. If you differentiate this Lagrangian with respect to x dot, then you will get this. Okay, now del L by del y dot, you will get it is equal to mx dot only. So mx dot is equal to py, so you can replace this mx dot by py, then you will get px is equal to py plus my dot. You will get this px is equal to this one. So from here you can write y dot is equal to px by m minus py by m. So this implies y dot is equal to this, and from here you can find x dot. Py is equal to mx dot, so x dot will be equal to py by m. You will get py by m. Now, so let me scroll down the page. So as you see, we have got this Hamiltonian here. This is the Hamiltonian. So if you put the values of y dot and x dot in this equation, then what you will get? Then from this equation you will get h is equal to px py by m plus py into px by m minus py by m minus half py into py by m minus py px by m minus py by m. We will get this. Now here you see what we have done. We have replaced this x and y dot by these values that we have got here. This is y dot, this is x dot. And here you see this term half mx square, this term here you can see half mx square, it can be written as half mx dot into x dot. So replace the x dot by p by m, so this is p by m, and replace mx dot by py, because py here you see we have got py in this equation, py is equal to mx dot, we have already got, use this here. So that's what we have got. And if you simplify this, here you see it's very simple, this term and this term cancels, then you must get px into py by m minus, so here py square by 2m. So this is our result, this is the Hamiltonian that we need to find. So which option is correct here? Check which option is correct. So I think this is the option C. Option C is correct, I think. Yes. So here it is 1 by m px into py, that means this one, and this one is this. So hope you have understood this. Now let's move on to next. So this question was asked in December 9, 2015. So here Lagrangian of a moving particle in a plane is given in the Cartesian coordinate, this. So in polar coordinates we need to find the expression for canonical momentum, this PR. So which option will be correct? Now here you see in this case, so what is the Lagrangian given here? X dot y dot x square plus, sorry, not plus, x square minus y square here. So this can be expressed as x dot y dot minus taking common, you will get this. So this is the Lagrangian. So for this Cartesian x, y, and so what will be the corresponding corresponding polar coordinates? Remember this, r cos theta, and it will be r sin theta, y should be r sin theta, and r square is equal to x square plus y square. If you square and add these two equations, then you will get r square is equal to this, x square plus y square. So hope you have understood this. So now if you find x dot from this equation, then what you will get? X dot will be equal to r dot cos theta minus r sin theta into theta dot, you will get this. And from here you will get y dot is equal to r cos theta into theta dot plus r dot sin theta, you will get this. And here you see, if you put those values x dot, y dot and xy in this Lagrangian L, then L will be given by, so x dot we have got, let us put this r dot cos theta minus r sin theta and theta dot into r cos theta into theta dot plus r dot sin theta, and x square plus y square, that is I have told you here r square, isn't it? So it is simply r square, we can write. Okay, if you multiply these two and if you simplify this equation, then what you will get? You will get this, L is equal to r dot r cos square theta dot plus r dot square cos theta and sin theta minus r square sin theta cos theta dot square minus r theta dot sin square theta dot. We're gonna have this result, and minus r square at the end. So now I have already told you that momentum, so in this case it is represented by PR, that's going to be equal to always del L by del R dot. So if you find px, then we used to write del L by del x, isn't it? So now we have r, so we have to write del L by del r for pr, isn't it? So if you differentiate this expression with respect to r dot, then you will get r cos square theta into theta dot plus 2r dot cos theta sin theta minus r sin square theta into theta dot. So from these two terms, what we can take common, we can take r theta dot common, then within bracket you will get cos square theta minus sin square theta, cos square theta minus sin square theta. Okay, and this term, so this is r dot 2 cos theta into sin theta. So we have a trigonometric identity 2 cos theta sin theta, that's gonna be equal to here r dot is r dot simply 2 sin theta cos theta is sin twice theta. This is a trigonometric identity. So we have got this finally. And remember one more thing, this cos square theta minus sin square theta is cos 2 theta, isn't it? So what we have got, r dot sin 2 theta plus r theta dot cos 2 theta. So which option is correct? I think option 4. This option is correct, option 4. So hope you have understood this. So this is PR. Okay, so let's move on to next question. So now this is the question from NET June 2016. Here, canonical transformation small p small q small p to capital P capital Q made through the generating function. This is the generating function, and Hamiltonian is given by this. This is the Hamiltonian here. So we need to find the equation of motion for capital P and capital Q. So which option will be correct? First, let us write the generating function. So what is the generating function here? F of small q and capital P. This is the generating function, which is equal to q square into capital P. So here, so small p will be given by del F by del Q. Okay, that's gonna be equal to twice q capital P. So then what will happen? And one more thing, it is a function of small q and capital P. That's why we have got this is capital P here. So to find capital P, small p, we have to differentiate this f with respect to small q. Then to get capital Q, we have to differentiate it with respect to capital P, because it is not it is a function of P, capital P. So if you differentiate it with respect to capital B, then what you will get? Small q square. And from this, here you see small p implies root 2 capital P capital Q, and here small q implies root capital Q. So here what we have done, this small q value is put here. So it is put here. So that's how we have got this. Okay, so don't be confused that. Okay, now you see our Hamiltonian is given. H is equal to Hamiltonian in case of small p and small q. This is Hamiltonian in case of small p and q. So that is given as small p square by 2 alpha small q square plus b by 4, beta by 4, not b, beta by 4, q to the power 4. So here you see, so after transformation, this let us consider this new set of new Hamiltonian is H dash, which is of capital P and capital Q. That's going to be given by H plus del F by del T. So here you see this del F by del T, this term will be equal to 0. Why? Because here this generating function is not a function of t, that's why it's going to be equal to 0. So then you can write that, let me scroll down the page, h dash is equal to h means this, that is equal to small p square by 2 alpha q square plus beta by 4 q to the power 4. So now, so what we're going to do here, we're going to put the values of this small p and capital small q in this equation, in this Hamiltonian here. So if you put these values, then what you will get? So h dash will be equal to, so p we have got this, so that's why 2 capital P root capital Q by twice alpha. So q square is capital q square is capital Q, so we can write directly capital Q, and plus beta 4, and you know q square is capital Q, so that's why q to the power 4, that is q square whole square, that will be capital Q square. So you get this capital Q square. So if you simplify this, then what will happen? So it was p square, isn't it? So it will be whole square here. So after simplifying this, h dash is equal to 4 capital P square Q by 2 alpha Q plus beta by 4 q to the power q square. So here q gone, and this 2 cancels 4. So here is the final result, a final Hamiltonian, that is 2 capital P square by alpha plus beta capital Q square by 4. So what we need to find? We need to find the equation of motion for Q and P, capital Q and P. So this is Hamiltonian in terms of capital Q and capital P, isn't it? So Hamiltonian equations of motions, what are the Hamiltonian equations of motions? Q dot, that is given by del H by del P, and P dot capital P here, P dot is given by minus del H by del Q. So remember this formula. So if you find if you differentiate this H dash, in this case we have to write H dash. So with respect to P, if you differentiate it with respect to capital P, then you will get Q dot is equal to 4P, 4 capital B, P by alpha. So this is the function of P only, and this is not, and this is function of capital Q. So that's why P dot will be minus beta Q by 2. So this is the correct answer. So let me check the option, which option is correct. So if you check here, so what we have got, Q is equal to twice capital P, 4 capital P alpha. Where is 4 capital P alpha? This is 4 capital P alpha, and P dot we had got this. So if you check this results, okay, so our option is B, correct option is B. So hope you have understood this. Now so this is our next question, June 2016 net. Here we need to find the correct option, independent constants in this motion. Here Lagrangian is given. Okay, so here you see, in this case, so independent constant, that means which one will be conserved. So here you see, now let me tell you. First we need to find what will be conserved here in this case. So that will be the independent constant in this case. So here the Lagrangian, so let me make it smaller. So Lagrangian L is equal to half m x1 dot square plus m x2 dot square plus x3 dot square minus half k x1 square minus half k x2 plus x3 whole square. So remember one thing, if in Lagrangian it contains x dot and x, so let us consider x1 and x2, x1 here, x1 and x1 both, if both are in this Lagrangian, so as here you can see x dot and x1 dot and x1 is also present here, so then its corresponding momentum, that px will be conserved, sorry, not conserved, it will not conserved, it will not conserved. So similarly, if you see the other coordinates, x2 dot also present, x2 also present, so py is also not conserved. Similarly, x3 dot and x3 also present here, so p3, sorry, instead of px here I have to write px1, px2 and px3, these are also this remaining momentum also not conserved. Okay, and also here you see when it will be conserved, when this momentum will be conserved. So if it consists x dot, and if it doesn't consist x1, then px1 will be conserved. That is the concept, remember this thing. Okay, if both x dot and x present, then px is not conserved. Okay, so here as you can see, this Lagrangian L doesn't contain T also, so that's why here energy must be conserved. So that means if the Lagrangian L is independent of time, if L is independent of time, then energy is conserved. Okay, remember that thing. So our next question is, it came in December 2016 net. So here parabolic coordinates xi and eta given here related to Cartesian x comma y, such that x is equal to xi into eta and y is this. So we need to find the Lagrangian of two-dimensional simple harmonic oscillator. So we need to find it. So here you see what was the Lagrangian for one-dimensional simple harmonic oscillator. For that, L is equal to 1 by 2 m x dot square minus half m omega square x square. This was the, so instead of omega is equal to root over k by m, k is spring constant, we generally instead of m omega square we used to write k, but here I am writing m omega square because in this case m is present, so that's why I writing m omega square. Now you see all the options here contains omega square, so that's why I have expressed this in terms of omega. That means it was half m x dot square minus half k x square, so k is nothing but m omega square. So remember this. Okay, so now, so it was the Lagrangian for one-dimensional simple harmonic oscillator. So what will be in case of two-dimensional? In case of two-dimensional, we will have two coordinates x and y. So in that case, only x dot we have to write L is equal to half of m x dot square plus y dot square, and on the other hand here we will get half m omega square. Instead of x square only, we will get x square plus y square. So we get this. So here you see we have x equal to xi eta. So that's why x dot will be xi eta dot plus eta xi dot. Y is equal to half eta square minus xi square minus eta square. So y dot will be half into 2 here, xi into xi dot minus eta into eta dot. So here 2 will be cancelled, so we get so from here y dot is equal to, we get xi dot minus eta dot. So now put these values of x, y and x dot, y dot here in this Lagrangian equation, Lagrangian L. Before that, let us find x dot square. So x dot square will be xi eta dot plus eta xi dot whole square. If you find it, then you will get eta xi eta dot square whole square plus 2 eta xi eta dot and eta dot, and so xi dot should be there. I have done a mistake here. Then minus eta dot plus eta xi dot square whole square. So we get this. Then if you find y dot square from here, y dot, then you will get, if you square it, then you will get eta dot whole square minus 2 eta dot xi dot eta dot, then plus eta dot whole square. Okay, now if you add these two will be cancelled definitely. So then what you will get, then you will get x dot square plus y dot square is equal to, then you will get, if you simplify, if you add this and simplify these two, then you will get xi square plus eta square into xi dot square plus eta dot square. So you will get this after simplification. Okay, so similarly we can find x square plus y square. If you put the value of x and y and square, and after simplification you will get this kind of result, xi square eta square plus 4 xi square whole square minus 1 by 2 xi square eta square plus 1 by 4 eta square whole square. Then you see, if you subtract these two, then you will get plus half xi square and eta square, and combining these three terms you will get 1 by 4 xi square plus eta square whole square. If you simplify this, this term can be written as 2 into 1 by 4 xi square eta square, isn't it? And here you see this is a square twice ab plus b square. So this is what we have got, x square plus y square. So we have got x square, x dot square and y dot square, and x square plus y square. So if you use this value in this expression, in this equation here, Lagrangian, so then you will get the result, required result. Then what you will get? Then you will get L is equal to half m xi square, after taking this term common, we will get this xi dot square plus eta dot square minus 1 by 4 omega square xi square plus eta square. So this is the result, and here you see this is an option, I think B here. So that's how we get this answer. So hope you have understood this. So if you understood this, please share the video with your friends and please hit the thumbs up button, and if you are new to my channel, please subscribe.